Welcome to 2.4, Modeling with Quadratic Functions, Part 2. Writing equations to model data. When data have equally spaced inputs, that's the x values, you can analyze patterns in the differences of outputs, that's the y values, to determine what type of function can be used to model the data. Linear data have a constant first differences. So if you subtract the y values and the first differences are the same, you have a linear function. Quadratic data have a constant second differences. So if you take those differences and subtract them again, and they're all the same, then your data is a quadratic function. So you notice that f of x equals x squared, they did a t-chart. They did the first differences and they did the second differences, and the second differences were all 2's. That means that that function is a quadratic function. So we can use a table to help us determine if a function or if a relation is possibly have a quadratic relationship. So let's take a look. Writing equation or quadratic equation using 3 points. NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the heights, h in feet, of a plane t seconds after starting the flight path. After about 20.8 seconds, passengers begin to experience a weightless environment. Write an evaluated function to approximate the height at which this occurs. So we don't have the table. I apologize, I didn't have it down here, but let me enter it in. I'll write it down. All right, here is the data table of values that should have been provided, but it wasn't. I apologize. So we need to figure out if this is a quadratic function. So the first thing we have to do is look at the first differences and the second differences. First thing you need to check, though, is to make sure that you have a pattern going on in your x values. So let's take a look at that. So let's look at our x values. So we have 10, 15, 20, 25, 30, 35, 40. We absolutely have a pattern happening in our input values. They're going up by 5's. So it has to be some type of pattern. Go by 1's, 2's, 3's, whatever. 5's is fine. So now we're going to look at our y values. So we're going to figure out if this is going up, if our second differences are the same. So what we do is we take our first two values and subtract the bottom one from the top one. So 29,025 minus 26,900. That gives us 2,125. We do this again with the next two. So we take 30,600 and subtract 29,025 to give us 1,575. And we just keep on going. So we take 31,625 minus 30,600. We get 1,025. Then we get 475. We get negative 75. And then we take 31,400 and subtract 32,025. We get negative 625. Then we're going to do this process again. The first differences are not the same, so we know this is not linear. If this was the same, we know this would be linear. So let's do this again. So we do the second differences. So we take 1,575 and subtract 2,125, and we get negative 550. We take 1,025 and subtract 1,575. We get negative 550. take 475 and you subtract 1,025, you get negative 550. We see a pattern going on, right? But you need to check just in case. Negative 75 minus 475, negative 550. And negative 625 minus a negative 75 is also a negative 550. So the second differences are the same. That means we have a quadratic. So this is a quadratic function. That is our check. So step 2, we actually have to write an equation. Since we know that this is quadratic and it can be written in the form of y equals ax squared plus bx plus c. Now we have many points, okay? But what we do not know, we don't know the values of a, we don't know the values of b, and we do not know the values of c. But we know how to solve 3 variable systems. So we're going to choose 3 points. I'm going to choose just the first 3. Plug them into my blank equation and create 3 equations with a, b, and c blank, but I'm going to fill in the x values and the y values. So this is going to be our 3 equations. So let's look at equation 1. So our y value for our first point is 26,900. We don't know a, but we know the x value at this point is 10. So 10 squared. Plus, we don't know b, but we know the x value at this point is 10, and we do not know c. So let's write another equation. So here's another equation. We'll call this one equation 2. Actually, yeah, we'll call this equation 2. The first one we'll call equation 1. Because labeling is always good when we do systems of equations, right? All right, so the second point we're going to use is the 29,025. So y value is 29,025 equals, we do not know a, and then the x value is 15, so times 15 squared, plus b times 15, there's your x value, and we do not know c. Let's do the third equation. So our y value is 30,600. We do not know a, times 20 squared plus b times 20 plus c. So we have 3 equations with 3 unknowns. Now we're assuming that all of these points come from the same equation, so that should be the same a, the same b, and the same c. So that's why we can do systems of equations. So let's simplify these to put them in a form we're used to looking at. All right, so equation 1. All right, so we usually see our constant, our 26,900 on the other side, so I'm gonna put it over there. 10 squared is 100, so it's 100 times a plus 10 times b plus c is equal to 26,900. So there's our first equation. Equation 2, again, 15 squared. 15 squared is 225. A plus 15b plus c is equal to 29,025. Equation 3, 20 squared is 400. A plus 20b plus c is equal to 30,600. Now, yes, these are big numbers, but the cool thing is you notice how all the c's have coefficient of 1. So we can definitely use elimination here. Should be really quick and easy to find, at least to get it down to 2 variables. And we know these are long problems. We know this, right? So we're going to take equation 1, and I'm going to just take equation 1 and then equation 2. I'm going to multiply by -1 just so I have the opposite of, okay? So equation 1, I have 100a plus 10b plus c is equal to 26,900. And equation 2, I'm going to multiply by -1. So negative 225a plus negative 15b plus negative c is equal to negative 29,025. I'm going to simplify by adding them. Negative 125a minus 5b, and then c plus negative c is 0, gives you negative 2,125. We need to eliminate c again, so use two different equations. Let's use equation 1 and 2 the first time. Let's use 2 and 3. And let's take equation 3 and multiply by -1. So equation 2 is 225a plus 15b plus c equals 29,025. Equation 3, multiply by -1 is negative 400a minus 20b plus c is equal to negative 30,600. Going to add them together. We get negative 175a minus 5b, oh, that's a negative c. No c's equals negative 1,575. So we'll call that equation 4 and equation 5. Then we take those two and eliminate another variable. And it looks like our b values are almost opposite. So let's use equation 4 and 5. And we're going to multiply equation 5 by -1. So equation 4 is negative 125a minus 5b equals negative 2,125. Equation 5, we multiply by -1, is 175a plus 5b equals 1,575. We simplify, add those two together, we get 50a, wrote that wrong. No b's, and 2,000, or negative 2,125 plus 1,575 gives us negative 550. Divide that by 50, we get negative 11. So there's one of our answers. We'll plug this back in to one of our equation 4 or 5. I'm gonna choose 4. So negative 125 times a, which is negative 11, minus 5b equals negative 2,125. So we get negative 125 times negative 11 gives us 1,375 minus 5b is equal to negative 2,125. I'm going to subtract 1,375 from both sides. So negative 5b is equal to negative 3,500 divided by 5, or negative 5. B is equal to 700. So there's our second answer. We only got one more to go, and I'm going to choose the equation 1. So I'm going to plug in 100 times A, which we know is a negative 11, plus 10B, B we know is 700, plus C is equal to 26,900. Let's zoom in now. We're going to simplify this. That's a negative 1,100 plus 7,000 plus C is equal to 26,900. Add negative 1,100 and 7,000. We get 5,900 plus C is equal to 2,690, or sorry, 26,900. We're going to subtract off 5,900. We get C is equal to 21,000 for our third answer. So our answers, A is negative 11, B is 700, C is 2100, and with those numbers, we're writing our equation. F is h of x, right? Yeah, it's h of t actually. H of t is equal to ax squared, and A is negative 11, plus bx, b is 700, so plus 700x, plus c, so plus 21,000. So that is the formula that models this data. So if we were to graph all the points and graph this equation, it would fit the data. These type of problems do take a long time to solve because we are doing a 3-variable system. You just have to be patient and know that the A, B, and C are the same in all 3 equations, create your equation and solve them.